Hello class, this is section 3.2, Angles and Parallel Lines. Our learning target for today will be that we will be able to determine relationships between specific pairs of angles and use algebra to find specific angle measurements. This lesson is going to be building off of 3.1. We are going to keep using those angle relationships and those special angle pairs to find missing pieces between our parallel lines. So first, let's start off with a quick review of what we did at the end of last lesson. It says find the value of x and the measure of each angle. Justify each step. So here in my picture I see two parallel lines. I see two transversals because they're crossing those parallel lines in two spots. And then I see two angle measurements right here. First, I want to identify what type of angles these are. Well, they are on the inside of the parallel lines and they are on the same side of the transversal. So these are consecutive interior angles. If you remember from last lesson, consecutive interior angles are supplementary. So the first thing I can do to find x is write an equation. I can say that 3x plus 2x plus 50 is equal to 180. Well, I need to justify this step because in the directions it says justify each step. So why can I say this? I can say this because if you have parallel lines, then consecutive interior angles are supplementary. This is just a shorthand way of saying that. So now I'm going to combine like terms or simplify. Then I need to subtract 50 from each side, so that step would be subtraction. And then finally divide by 5 on both sides to get that x is equal to 26. So my last step was using division. It then wants me to find the measure of each angle, so I'm going to take what x is equal to and plug that back in for each of my angles. So the top angle is going to be equal to 76. And the bottom angle is going to be equal to 102. And I noticed that these are supplementary, so I did my math correctly. Alright, so last lesson we learned about the different special angle pairs and the relationships between them. Well, those are all actually theorems and postulates. So that's what we're going to go over on this slide. Remember that a postulate is just something that can be stated without having to be proved. It's just assumed that it's true. Theorems can be proved. So there's not much of a difference between the two, and I won't ask you that question on the test, just in case you were wondering what the difference was. So when lines are parallel, corresponding angles are congruent. Next theorem, when lines are parallel, alternate interior angles are congruent. The third one, when lines are parallel, consecutive interior angles are supplementary. The fourth one, when lines are parallel, alternate exterior angles are congruent. And finally, when lines are parallel, consecutive exterior angles are supplementary. So we're going to be using these theorems and postulates whenever we're doing proofs or having to justify statements that I give you. So let's use those theorems to find different angle measures. In the picture on the right, if the measure of angle 2 is equal to 120 degrees, we need to find the following angles and state what theorem we used. So if angle 2 is 120, what would angle 3 be? Well, angle 3 would also be 120 degrees, and the reason why is because vertical angles are congruent. Even though we're learning these new angle relationships, you still have to remember everything we've learned prior to that. You need to remember your vertical angles and your congruent angles and your supplementary and complementary angles. Alright, next one. We know that angle 2 is 120 and we know angle 3 is 120 now. We need to find the measure of angle 7. Well, angle 7 is also going to be 120 degrees, and the reason why is that corresponding angles are congruent. So we can see that since this is 120, I can say that angle 7 is 120 because they're corresponding angles. And then finally, we need to find the measure of angle 8. So the measure of angle 8 is going to be 60 degrees. And the reason why is that linear pair angles are supplementary. So you could have used a couple different reasons for why that was 60 degrees. Right here you can see 7 and 8 are a linear pair. You also could have used the fact that angle 2 and angle 8 are consecutive exterior angles, which would have made them supplementary. Using the picture at the left, find the measure of each angle and tell which postulate or theorem you used. So it's going to give us that the measure of angle 8 is 110. And from this angle, we can find angles 1 through 7. So let's start with angle 1. First, you need to think to yourself, what is the relationship between angle 1 and angle 8? Well, they're on the outside of these two parallel lines, and they're on the same side of the transversal. So that's going to be consecutive exterior angles, which makes them supplementary. So the measure of angle 1 is going to be 70 degrees because consecutive exterior angles are supplementary. Now moving on to angle 2. There are a couple different relationships you could use. I know that 2 and 8 are going to be alternate exterior angles, and I know that 1 and 2 are supplementary because they're a linear pair. Either of these would work to give you that angle 2 is 110 degrees. I'm going to use the fact that they're alternate exterior angles, but if you want, you can just say that these two are a linear pair. Alright, the measure of angle 3. Again, we can use a lot of different relationships. We know that 1 and 3 are going to be vertical angles, so that tells us that 3 is 70 degrees. We know that 2 and 3 are supplementary, so that means that 3 is 70 degrees. So either reason would work. I'm choosing the one that vertical angles are congruent. Alright, angle 4. Again, this one has a couple different ones you could use. I know 2 and 4 are vertical, 1 and 4 are supplementary, and 4 and 3 are supplementary. I also know that 4 and 8 are corresponding. No matter which relationship you use, you will always get that angle 4 is equal to 110 degrees, which says corresponding angles are congruent. That's just the theorem that I chose to use. As long as you can justify why you say an angle is a specific measure, your answer will be correct. You may have a different answer than me, but as long as it's one of those special angle pairs and it's true, then you're fine. Alright, moving on to angle 5. We already know that angle 5 is going to be 70 degrees, and I chose to use that 3 and 5 are alternate interior angles right here. We know that alternate interior angles are congruent. Angle 6, I chose to use the reason that angles 6 and 8 are vertical angles, and vertical angles are congruent, so angle 6 is 110 degrees. And then finally, angle 7 is going to be 70 degrees. And I chose to use alternate exterior angles. You pretty much could have used any of the special angle theorems to prove that this one was 70 degrees. Alright, now we're going to find the value of the variables in each picture and explain your answer. So when I'm asking you to justify your steps or explain your answer, you should probably be using one of those theorems that we just went over at the beginning. So on the picture on the left, I have two angles between these two parallel lines. They're on the same side of the transversal, so these are going to be consecutive interior angles, which means that they are supplementary. So consecutive interior angles are supplementary, so I'm going to add the two angles up and set them equal to 180. Then I'll solve my equation to get that x is equal to 11. I want you to try the second one on your own. I will show the answer in just a second. For this one, the relationship between these two angles is that they were corresponding angles. Our theorem says that corresponding angles are congruent. So you're going to set their measures equal and get that 30 is equal to n. All right, time to try a proof. Write a 2-column proof to solve for y. We are given that angle 4 is 4y plus 30 and angle 5 is 7y plus 6. So I'm going to go ahead and fill in my given statement and reason. Whenever we're working with these special angle pairs and parallel lines, you always want to look at what's the relationship between the two angles you're given. So looking at angle 4 and angle 5, what type of special angle pair are these two? Well, angle 4 and 5 are alternate interior angles. How do I know they're alternate interior angles? Because of the definition of alternate interior angles. Next, if they are alternate interior angles, what do we know about their measures? Well, we know that they're going to be congruent. The reason for this is the theorem that we went over at the beginning, stating that alternate interior angles are congruent. Now that I have that these two are congruent, I'm working my way to solving for y. So my next statement says that angle 4 is equal to angle 5. The reason I can go from congruent to equal is using the definition of congruence. Now that I'm setting their measures equal, let's go ahead and plug in what they're actually equal to. So we're going to have 4y plus 30 is equal to 7y plus 6. This is using substitution. And now I have that equation to solve for y. I'm going to subtract 4y from both sides using subtraction. Subtract 6 from both sides using subtraction. And then finally divide by 3 on both sides to get that y is equal to 8. And that's using division. See, that proof wasn't so hard. It's just making you give a reason for each step. That's the end of our lesson. Make sure you fill out your WSQ.